So when a pin is configured as a digital input, it will read a logic 0 when 0 volts is present on that pin. And it will read a logic 1 when a positive voltage is present. And for the case of the LPC 1768, this corresponds to 3.3 volts. So probably the most common method used for an input is a push button. So you've obviously got lots of embedded systems, devices around, they've always got lots of buttons on them. So the voltage on that pin that the button's connected to is determined by whether the button is pressed or not. So we also need to use pull-up or pull-down resistors, depending how we connect the switch. Now these can be external components, so an actual physical resistor, but microcontroller GPIO ports do tend to have internal resistors that we can kind of switch on and off using software. So we'll first look at pull-up resistors. So in this configuration, the pin will read a logic 1 when the button is not pressed. So the actual pin has got a very large input impedance, so this current flowing into the pin is very small, and basically for all intents and purposes we can say the current flowing in from the positive supply is 0. So we know, so this voltage across the resistor will be 0 volts, and so the pin will be connected to 3.3 volts. So when we don't press the button, so when you can see when the button is open or the switch is open, the pin is connected to 3.3 volts through the pull-up resistor, and we read a logic 1. Now when we press the button, so this, if we press the button or close the switch, you can see now that the pin is just going to be connected to 0 volts through the closed button, and so they'll be connected to 0 volts, and it's going to read a logic 0. So this shows here, so the case where the button's pressed, it shows us why we need this resistor, because without that resistor, there's a connection now between the positive supply and ground. So without that resistor, it'll just be a short circuit between our power supply. So we need to put a resistor in. So these values are normally at least, normally greater than 10k, because when the switch or the button is closed, you're going to end up getting this current. There will be current flowing across the power supply terminal, so that's going to be 3.3 volts. Divided by R. So you want a big value of R to minimise this current, because that's just wasted current, wasted power, wasted battery life. So you need to use a big resistor to make that current as small as possible. So this is our Embed board. So you can plug that into a breadboard. Then V in. So you could power this. So V in and ground. So get wires here, connect it to a 9-volt battery. That will power this board, and then we could connect up a switch. So we wanted to use this pin, we put a switch or a button in, connect that up. So that pin will be connected to ground, so obviously that'll be connected around here. And then when the Embed is powered, when this Embed board is powered, we get 3.3 volts from here. So this will be a 3.3 volt line. So we can just get a resistor and connect it up to so that'll just be a resistor, say 10k or something like this. So you can connect it up, but it is possible. Sometimes you don't need, this is when we're using external pull-up resistors, so sometimes you might not need this, because you might decide to use internal. So actually inside of the microcontroller, there's actually a resistor internal. So if you switch on that resistor, so you can, there's the mode register in the GPIO peripheral. You can use that register to turn on pull-up or pull-down resistors. So by doing that, you can alleviate the need for having an external resistor. Now we're going to pull down resistors, so these are the opposite, so it gives us the opposite logic. So in this case, it reads the logic 0 when the button is not pressed. So you can see when the button's not pressed, so the button or the switch is open, and then there'll be no current flowing. So again, I'll just be connected to 0 volts here. There'll be no current flowing through the resistor. We'll just have a 0 volts on the pin. And then when we do press the button, that's obviously just going to connect the pin to 3.3 volts, and we'll read a logic 1 here. And again, this, we do need the pull-up resistor, because otherwise, in the case where the switch is closed, you're just going to get a current path between your power supply. So you need this big resistor to limit the current.